there's a whole other way that I've learned that deuterium plays a role. And if you let me explain this part, it's fascinating. The last year, I've been working with a group of scientists that includes Barry Ninham. He's an Australian scientist who spent years also in the US, but he's there, and he has published a series of papers, just recently the fourth one, that are, some would say, seminal papers that introduces to the world of nanobubbles. And this is utterly fascinating because it turns out that maybe for the last 300-400 years, I think it is, we have basically ignored, omitted the fact that dissolved gas plays a tremendous role in our body. And all the research, all the biochemistry, the colloid, surface chemistry, physical chemistry, they have all ignored it. None of them have included it in their considerations. And if you don't take dissolved gas in consideration, all the reactions change. Everything's different. So this is a whole other piece of why the way we currently practice medicine is just on very shaky ground and is missing fundamental parts. So it turns out that we breathe very differently than we do. I'll start there because that's really important to understand. So we've been told, we have in our atmosphere approximately 80% nitrogen and 20% of oxygen. And so we breathe in magically in our lungs, in our little alveoli, the red blood cells can just pick up the oxygen and off they go. Well, that's not what happens at all. It turns out that we actually breathe in the combination of both the nitrogen and the oxygen gas. And when that enters your alveoli, there is a 3D kind of honeycomb structure that then forms these teeny little nanobubbles. And those are made up of both nitrogen and oxygen gas. That then perfuses the vasculature. And in the capillaries is where the oxygen, not all of the oxygen, but some of the oxygen partitions into red blood cells. That's where the exchange happens. So this is fascinating. And it turns out that all of our vasculature and all of our cells, all of our tissues, everything has a layer that is called the endothelial surface layer glycocalyx complex. It's a mouthful, but basically, if you think of a cell, and we have given all sorts of wonderful properties to the cellular membrane that really, if you think about it, are impossible, that couldn't all be managed by that teeny little structure. So scale-wise, if you think of it, a cellular membrane is 3 nanometers, and then you have a layer of the glycocalyx, which is 50 nanometers. And this layer is super interesting. It's a interwoven kind of bicontinuous network of water tubules. And this actually directs all of the cellular traffic in and out of the cell. And it's also a neural network. And then from there is another layer that's 20 times that. And that is made up of these sulfated polymers. So you can think of that as like grass from, ocean grass. And that's highly sulfated. And that then is populated with the nanobubbles. And ultimately, the integrity and the structure of this layer determines the exclusion zone that happens above this nanobubble layer. And if this layer of the glycocalyx part, if that has a lot of deuterium in it, the actual structure of it changes, and the ability of water, of any kind of compound to move through it or traffic to happen changes. So that's fascinating, obviously. So these water tubules can change depending on the structure, the ion concentration, or, for instance, too much glucose or too little insulin. The curvature of the tubules changes, and then the connectivity and the conductivity changes. So then the entire mechanism kind of shifts. So, through metabolism, we produce constantly CO2 bubbles. So that's the other part of the bubbles that's present. And the CO2 is really important in eliminating infections of any sorts. So that's, it's just, yeah, the whole world opens up. I just created a page on my website that seeks to explain it and summarize it in a way. It's difficult because it's a 50-page paper, this last one that they put out, but it's really, really fundamental, and another reason why we need to do so much more research and understanding of how it all happens. Yeah.
Hey everyone, really happy to announce a new sponsor for the show and for everybody down in Australia, Stockman Steaks, who are delivering high quality grass-fed and finished pasture-raised beef and other meats, flash frozen and vacuum sealed to your door, something that I've been enjoying a lot of myself recently as well. They also have a great range of specialty items such as high-fat keto mince and carnivore beef and organs mince with liver, kidneys, and beef heart as well. So use code Chaffee today for a free order of beef mince or another specialty gift along with your order at stockmansteaks.com.au, and I'll see you over there. Thanks, guys.
Yeah. Does that make any sense?
Does, yeah. Well, the thing is, I mean, there was, as it's always explained to people, air goes in your lungs and then something happens and there's gas transfer, and it's just, using very broad general terms.
That's right.
Describe this, but no one's saying exactly how that mechanism works. We have a lot of mechanisms for different sorts of things. We talk about the inflammatory cycle and things going through and have this laminar flow, but then something happens and gets more congested, and then they actually have to become sticky and they're able to hit the wall. And we have all these little steps and mechanisms, and they explain those out, but then they just say, yeah, there's gas transfer, something happens and science happens, and then all of a sudden you have oxygen in your red blood cells. Obviously there's more to that, and understanding how that exactly works, and you can see these other parts of it, and that's very interesting. I hadn't heard that you have a higher deuterium level in those layers, and that's going to interrupt gas transfer. But
yeah, and if there's none, that's another piece. If there's none, the layer will collapse. So that's no good either, which is why this whole piece about, I think, deuterium regulation is key, not just depletion, which is what you hear. Yeah, it's too much. You don't want to do that either. We need it, and it has many other functions, and it's also believed to play a role in the bloodstream as a source for UV light. So this is a whole other piece. Once you start diving into that, how many of our proteins and hormones in our bodies need to be, the hormones need to be, they have an absorption range in the UV light spectra, which is amazing. And back in 2019, I'm Dutch, so Roland van Wijk has written some amazing books on light shaping life. And I actually went and visited him in his lab, and we had a conversation about it. And I tried to, it's always a great challenge for me to get scientists to kind of look outside of their box and add some other pieces to it. And I wanted to talk to him about deuterium, and he did not know about it, but it was fascinating anyway. His books are incredible, and that will tell you that our bodies produce, extreme low level UV light, and that actually activates many, many processes. And in fact, it controls mitosis. So that's just a whole other piece, how deuterium plays in our bodies.
So deuterium itself emits a bit of light, or some sort of process?
There is a process. I don't know of the exact details. And the truth is, there is no researcher that has, described this and published this. And I asked Roland van Wijk about it. Sorry, I'm saying his name in Dutch, but it's Roland van Wijk is what people call it. Yeah. But he didn't know about it. He does not know where it comes from. But if you look at a deuterium lamp, I don't know if you ever heard of that, but that creates, you can look it up, but that gives off UV light. It's fascinating, and so it is under pressure. That's how it happens. So it is assumed that also takes place in our bloodstream, and is it's important for all the amino acid, the different amino acids to activate them. So yeah, there's a lot. There's so much.
Yeah, I mean, I remember seeing a video. I came across it recently as well, actually. But when a sperm meets an egg, and different sperms will not be able to get purchased, and then one does, there's a flash of light at the moment
Yeah.
of conception, which is really interesting. But it's an actual measurable flash of light. And you can see it on video, on powerful microscopy, and it sort of goes around from one side to the other, just like that. Just
Yeah. Yeah.
yeah. And so obviously, I mean, so it is happening. We do know that, and listening to Jack Cruz and yourself, it doesn't surprise me that the body is emitting light in other ways, and I'm it's not going to do that for no reason. I'm sure there's this whole quantum side of our body that plays a part in.
That's right. We truly are electric. We are. Yeah. And
Yeah.
if those are interfered with all of the current, world that we live in, with
Mhm.
these magnetic frequencies and the blue light, and yeah, it's on and on. This affects all of our functioning. So this is a whole other way to think about it, and why we need to address these pieces so urgently and so importantly. I really talk about my clients. I try to explain that, the environment that you lived in which that allowed you to create this cancer, let's say, or whatever else is the issue, you must change that if you want lasting success in reversing what's happening. And that's likely the hardest part, for people to do these pieces. But I think it's really crucial. And yeah,
Yeah.
that's what we all work on. Yeah.
So how bad exactly is blue light? Like artificial blue light, obviously.
So I think it's truly detrimental for us, and it forces us to truly change. So this is that piece about palm seed. And basically, there is something called a CLIP enzyme, and that gets generated, activated through blue light, and that causes us to increase our glucose and insulin levels. And we don't have to even eat high glucose foods for that to happen. So you can have insulin resistance um, just by blue light. And I think this is the data that we're also really seeing from India, where we have the greatest population that is skinny, that it has insulin resistance and diabetes. That's the largest, it's their greatest health challenge. And so, we have sensors everywhere in our skin, and there's so many pieces to it. I'm not even clear exactly on how best to summarize that for you, but it's just devastating. It's devastating for our eyes, for our skin. I have my yellow filters on here. I'm working only on an Ethernet cable so that I don't expose myself even further, even though there's enough coming from this anyway. I've tested it. But this is at least the least damaging that I can be. But ideally, we should all be sitting outside or have
Mm.
plexiglass in our windows so that we at least allow for the red light to come through, because regular glass does not allow for that. So, yeah, we have to really change the way our homes are built, how we do our days. Um, and that's difficult because most of us are behind computers
Mm.
on a daily basis. Yeah.
Yeah. Do we understand the mechanism behind blue light causing insulin resistance and elevated glucose?
Yeah, this is through that POMC gene.
Mhm.
And so the POMC has to be activated by UV light, by UVA light specifically. And once that is activated, you produce the different forms of melanostimulating hormone, the alpha, the beta, the gamma, and that then gives rise to melanin. And melanin is ultimately the most important semiconductor in our body that can absorb all the light spectra and then use that to further charge separate water and increase our own metabolic water production, and then of course release electrons again, and those electrons will add to the net negative charge of the cell. So this is an amazing and you know, Dr. Cruz can explain this in much greater detail, but it used to be like all other animals, they have their melanin either in their feathers or in their skin. But we have all internalized it, and it's inside of our brain, it's inside of our cochlea, it's inside of the ovaries. I think is a really high amount of melanin, but all of this is extremely important for functioning. But if we are not getting UVA light, then we don't have that activation, then we don't have the melanin, then everything starts breaking down. And that's ultimately the part of it.
Hey guys, just want to take a second to thank our sponsor, Carnivore Bar. I don't promote many products because honestly, all you need to be healthy is to just eat meat. For those times that you're out hiking, road tripping, or stuck at work and you want a nutritious snack that is just meat, fat, and salt if you want it, the Carnivore Bar is a great option. So I like this product not because it's just pure meat, but also because I want the carnivore market to thrive as well. And the more we support meat-only products, the more meat-only products there will be available in the mainstream. So if this sounds like something you'd like to get behind, check it out using my discount code Anthony to get 10% off, which also applies to subscriptions, giving you 25% off total. All right, thanks guys.
Yeah. Well, yeah, I really love the light stuff, and I think that it all comes back to just living in a biologically appropriate way for our species. You know, we're going away from that. Obviously, you know, I come at this from a nutrition standpoint because it's a huge issue. But light is a massive issue as well, because we're in no way in a natural light environment either. And I'm very fascinated by the work that's coming out in that field. I have a number of colleagues that they're just really blown away by this as well. And they've just sort of shifted their whole practice. Yes, they do ketogenic, carnivore, and just all that sort of stuff. But like probably the biggest thing is they're just like, you need to be outside. You need to get rid of these lights and all that sort of stuff. That's one of the major things that they do. So it's very, very interesting to me.
I mean, I think we have to, because it's just not enough. It's not enough changing the food. We know that. And, you know, some would say light trumps food. It's not going to do it for you just by that. It's a huge step. And I know it will make a difference, but it won't solve all your problems by no means. You know, that's really what we have to recognize, that we have to go there. Yeah.
I guess we can think about it as you're getting fed in different directions and different means. You know, food is one source of nutrition, but you're getting other sorts of inputs from the light environment, and so you need that as a source of nutrition as well. And it's never a good idea to eat poison, and that's why we try not to eat poison and change our diet. But it's also not a good idea to get exposed. You know, you could get light poisoning as well. And you know, one of the healthier people that I've met is this lady Maggie, who you know, she's 80 now, 84-year-old, turning 84-year-old rancher. She's been carnivore her whole life. She's been crazy healthy, and she's still at 84, you know, working 16-hour days, sometimes 36 hours straight if she has to, during calving and all that sort of stuff. She's just up all the time, and doing 2-hour checks overnight, all that sort of stuff. And she's doing this all herself. It's not like she's just, you know, there with a big white hat, just watching all her field hands, you know, do their work. She's doing it. And that is probably a huge part of that. She's physically active and she's doing a lot of stuff with her body. So her body's staying strong and healthy. But But also she's outside. She's
She's
outside every
outside.
single day.
That's
Every
exactly
single
right.
day, all
Yeah, I
day.
know. I listened to that podcast. It's fascinating. She's unbelievable. She's a powerhouse at that age doing what she's doing, as you know. That's very rare. But yeah, she's outside. That's the key. And she's also into cold, she's in cold as well. And that's another part of it. Cold is extremely useful. If you don't have the light, at least you have that part that will then do the whole cold thermogenesis piece that is so crucial for our mitochondria as well. These are the two ways for us to do it, light and cold. Yeah.
Is it, in the winter months, like, is it enough to people just to get outside and get the light in their eyes, or you need it on your skin as well, or how does that work?
Well, there's not much UV light, and this all depends on, of course, where you are on what latitude. But yeah, I think if you get it in your eyes, most importantly, is absolutely key. But if you can do the cold and as well and the sunshine, that would be even better. So, submerging yourself in cold water is really a whole other level. Yeah.
And then you mentioned how actual, silicon glass will block out red light. What's the importance of the red light?
So infrared light, or the different spectra of red light, are there've been great podcasts on that as well. Max Gulhane did some beautiful ones, and basically that we have in our mitochondria the different complexes, and on complex 4 it is fueled by infrared light. And so you upregulate even the production of your metabolic water at a higher rate doing so. And infrared light in that sense is beautiful and healing. And my clients really love it. In some cases, it helps you with your, different hormonals, with hair growth, for pain, all of it. It's a very useful light source to use. Yeah.
So even as an artificial, I mean, not getting it directly from the sun. Obviously, you're getting red light from the sun, being out in the sun.
Yep.
But I mean, like getting red light lamps, is that
Yeah.
beneficial?
Yeah. Yeah, absolutely. I think it's useful to use for treatment, but also in the evenings when we are still on computers, or we want to light our space, to definitely balance the spectra. And I will have some infrared light on as well to complement that. Yeah, to be kind to our skin and not, it's difficult in most places. You can't even buy the incandescent light bulbs anymore, but that would be a preferred. There is an executive order, I think it was signed, that you can choose again to buy the light bulb of your choice, but
They made that illegal. Like, why,
they did.
it's
They
just
did.
insane.
It's
Yeah.
insane. But I think there are ways of getting them. And so that would be another approach, to at least make sure that you're not under LED or compact fluorescent light bulbs, which they just destroy your melatonin.
Yeah.
But yeah, I think infrared light is very useful, and I use it as a source in the evenings for lighting my environment.
I do wonder, like, why they would ever make incandescent bulbs illegal, and you have to get this blue light spectrum sort of LED, in the whole sort of when you see enough of this stuff, you start becoming very cynical. You start seeing people doing something on purpose in
Mhm.
order to manipulate people in some certain way,
Yeah.
and they're doing it in one area, they're often doing it in other areas. And I know Dr. Cruz talks about what is it, MK Ultra project that the CIA did, looking at stimulating certain parts of the brain. You can make primates very docile, and he
Yep.
knows about this because he was in the neurosurgery program at Tulane that was
That's right.
doing that, putting the probes in
Yeah.
there. And then they found that, like, they, as in Jack and the researchers, found that giving certain frequencies of blue light stimulated the same parts of the brain, made them very docile. And that happens to be the exact spectrum of blue light that comes in all our LEDs and on our computers and on our TVs and on our
Yeah.
phones.
Yeah.
And so that seems purposeful. And then when they're making it illegal to get the, like,
It's
you're allowed to have, or you were allowed to have them, but you just weren't allowed to sell them, so they ran out. And and now you have to get these lights that are toxic in this way. and make people docile and controllable in lab experiments. That just, I don't know, it just sounds some alarms in my head.
And I think there's a great variety in what substances people can use. And I agree with Gabor that we should not be using high-dose vitamin C or synthetic glutathione for that matter at all. I think regardless, I don't think those are great, period, on deuterium depleted water or not.